get into it. Welcome everybody to the AI Engineering Bootcamp Cohort 5. We are in session 9, kicking off week 5, talking about fine-tuning. And today we're going to talk fine-tuning embeddings. Another way to think about this is adapting to our domain. We can think about taking our applications we build and then just aligning them a little bit more with the specialized language we use in our space. First, as always, we're going to do some Build, Ship, Share shout outs. Just a real quick thing. We are working on best ways to do this. In the newsletter, each week that goes out to now 13,500 people, we do shout outs. So if you're building, shipping, and sharing outside of cohort stuff, we would love to continue to highlight you. Shout out to Ben this week for getting the nod in the newsletter here. Hopefully you gained some followers from that, Ben. And then Mike C, many of you guys know, he is also consistently in the newsletter. I'll show you what for, but we are going to sort of drop just the cohort sharing. We want you guys to take it to the next level. That's going to be the vibe of today. Shout out to Ben for building some awesome prompt to VR stuff. If you're interested in this kind of project, I would reach out to Ben Gibbons. Cyberpunk Workshop Indoor Garden Palace, Beach Paradise, love this. And then Mike C, he's every week, for those of you that don't know, he's keeping us up to date. What's happening in the Bay Area? This is last week. He's hanging out with the Crew AI CEO. And he's telling us also about the love hack that he will be attending this weekend. Happy Valentine's Day, everybody. And I did talk to at least one student over the last week, and it really is for real, right, Mike? That people can hit you up and you will go and meet up with them in person. You'll tell them where they need to be. You'll tell them where the stuff is happening. And you are a great guy to connect with, as well as Sriracha and others in the community. Isn't that so?
For sure. So there's a lot of things going on. And no, you don't have to be in San Francisco. There are lots that I post that are online as well. So the directory, the biggest directory is the Cerebral Valley directory. That spreadsheet is at the bottom there. There's 104 events in February in the Bay Area, and it's not even a leap year. So, I mean, you want to get out there. Why go? It's a mixture of different types of events. So you're going to have some that are like super intense, where they're going to have, like yesterday, I was at the AWS Loft, where you had Quadrant and you had Crew AI and you had Arise Phoenix. So you get a in-depth, detailed technical. If you want to have something more light, like last week, it was Llama Lounge, and it was more like the VCs mixing with the engineers. So you get that as well. And then you have hackathons and conferences. So, there's lots out there. So check out the list and pick and choose. It's a buffet. It's a technical buffet, and your plate's only so big. So pick and choose.
That's right. Thanks, Mike. And then there's always hackathons going on that are easy to get teams, even remote teams around the world, together with in the community. It happens all the time. Now that you're sort of getting into the fold and you're getting the skills, these are the kind of things you want to be going out and doing to really build that portfolio, build that exposure, and start meeting some of the movers and shakers in the industry, like the CEO of Crew here that Mike was hanging out with last week. Okay, so if you want to know more about that, come to the Build, Ship, Share sessions on Monday. Also, this week, we did highlight Akash. He's from the last cohort. He actually built, shipped, and shared Publicus, which is now a company, we talked about it in session 1, seeking funding up in Canada, changing the game for the government and how they deal with RFPs, requests for proposals, and how the contractors can really streamline their processes and operations. So check that out. And just shout out to Wiz. I'm also going to highlight each week my favorite Wiz post of the week. And that's going to happen every Monday. Join us again. We're going to start doing shout outs for just the creme de la creme of the cohort. So keep stepping your game up, guys. I really love it. And we are going to also, as we talk about homework, give you guys the shout outs that you deserve as well. For instance, homework number 5, 37 of you submitted. We had a tough grader on this one, or maybe it was you guys were just not as dialed in. I'm not sure. Kat, what did you see and how did you feel about the overall quality of submissions coming in from the 37 students you looked at?
Hi, I felt like everyone was doing really well. I don't think that I was that harsh. Well, there was like one question in particular which students had a hard time with, and it was the question whether we can like limit the number of rounds for graph. And usually people put there like there is no default limit and it can go to infinity, while there actually is a default limit. So that was very often the problem. Otherwise, I felt like everyone was doing really, really good. I was impressed. So
Nice,
good job.
nice. Are we, well, Wiz gotcha with the gotcha question. Way to go, Wiz. Excellent job. And quick shout outs to everybody that did do a share. Great work. Keep it going. When you post on LinkedIn or Twitter, we will always repost you and then we'll shout you out on the homework. We did see some great lessons. You know, we talked about these last week and we'll continue to keep you posted as the grades start coming in. Coming up, we have Vincent had some technical difficulties over there in France today. So this has been rescheduled for Thursday. In case you wanted to make it, you still can. It'll be right before my office hours in the AI5 lounge. And then join us this week to talk DeepSeek R1 tomorrow. If you miss it, that's all right, because we'll be fine-tuning our own reasoning model in class on Thursday. It should be a lot of fun. So last time you guys gave us feedback, Ragus is cool. We agree. I'm liking the length of this yay feedback slide. Some great suggestions coming in. Bit more time on the code. We'll see what we can do for you today. We are going to do we're going to do a bit of a big job this week to try to teach you fine tuning. As you'll notice, if you don't have a background in transformers, it will be painful. Just stick with it. We got to get end to end. And looking forward to understand more on evals. I'm sure you will. Signing up for 2 accounts and API keys. This was something that we heard like twice, and I want to just make sure everybody's super clear on this. Every time we have class, we send out an email an hour before class goes out, and we tell you, hey, this is what you got to make sure you do before class. Every time we leave class, we're posting the pre-session work. And there was one API key before last time in that email, in the pre-session a week ahead, and really like, if you're not getting these emails, if you're not seeing the pre-work in the emails we send in the Discords anywhere, please reach out to Sriracha and let us know. This was something that one of the students did see in Discord. This is something we really want to figure out how to not have be an issue for future students. So if it's an issue for you, I'd love to know why and how we can try to avoid it in the future. All right, add Chris's talking points at a high level to the notebook. I think, you know, because he is the whiz, he kind of just, you know, has the riz and he kind of goes here and he goes there and it kind of just depends. So it's hard to do, but he's taking this into consideration to try to give you even more of the good stuff that you're looking for. How Ragus works, high level system design. Waleed, you should definitely help Ragus guys out with this. Every time I create a freaking diagram, they change the whole system on me. It's very tough. I would love to see what gets put together and steal anything that you guys make that's any good at all. I'm always working on trying to sort of wrap my own head around exactly what's going on there. But, you know, lines with boxes connected are really great. Everybody loves them. Definitely pick up Excalidraw and try to see what you can do to illustrate Ragus. It's not that easy to fully grasp. It's not, but you know, we're getting there, and we're really starting to get now into the depth after this last week of breadth. I feel the new eval metrics were ran through too fast, so it goes. There's many of them. Would it be possible to post the slides in parallel to the lecture? I am going to try to do this for you. Yes, thank you for asking. This would make Sriracha happy, and it would make me happy too if we could get to this point. Okay. So thank you for that feedback. More time to talk with peer supporters. Also, shout out to Mike C. The way he explains concepts, so amazing. We agree. Wiz, quick question. To build a robust system, are the patterns we've seen so far sufficient, or are we going to need things like reflection or tree of thought and more advanced things? What are your thoughts on this, based on how far we've gone?
Yeah, this is a question we get every time, and every time we do the cohort, we kind of by the end we reach a new level of complexity, right? Now, at some point, it's just complexity for complexity's sake, and it hasn't been, let's say, battle tested, right, in actual production applications. I mean, this is still true largely of just agent patterns, period, right? The production utility uh, is not necessarily well understood, et cetera, et cetera. What I would say is that the patterns that we leaving you with is what most RAG systems, most AI powered systems that are in production and adding value to companies are leveraging. Uh, Again, this is going to constantly creep up in complexity over time. So too will our content. But for now, you're set to build, I would say, over 80% of actual value adding software or application flows that utilize AI. Self-reflect or reflection and tree of thought. Like tree of thought is a cool idea, but prohibitively costly. It's not something that I'm going to recommend you to pursue. In fact, I would very strongly recommend you avoid it at all costs. You're going to pay a lot. You could just pay for a better model, for instance, right? Especially now that we have things like R1, which kind of fill that niche a little bit better. But yes, you're going to be set up to build most of the actual like a workhorse of AI applications that exist today.
Yeah.
With this
And if
stack.
reflection becomes one, we'll add it to the core curriculum, and you'll have seen it by now. All right, good stuff. Thanks, Wiz. And let's go ahead and align ourselves to today. Again, we're going to cover fine tuning this week. And if you're not familiar with classic ML, with training, with supervised fine tuning, with unsupervised learning, with these concepts in general behind AI and ML, you will struggle this week with some of the concepts, hands down, especially if you didn't go through the LLM Foundations course. That said, you won't struggle too much to not be able to build it because you have all the tools you need to be able to fit this in to your systems that leverage RAG, that leverage agents, etc. Fine tuning is, again, a fine tuning, and it's not something that we're going to really worry about straight off the bat. And we'll talk about that throughout the day and throughout the week. We want to understand today how to fine-tune embeddings for RAG, okay? So we want to enhance our ability to retrieve domain-specific stuff. We're going to talk about how to do SDG, our good friend synthetic data generation, to create question context pairs that we can use to fine-tune our embedding model that we use in our retrieval system. So the idea is that if we build a RAG, we do SDG, we're going to then evaluate with the evaluation data, baseline it, then we might make a retrieval improvement like we've seen with re-rank. We might also try to improve by fine-tuning embeddings, which is a different kind of SDG. Either way, it's all towards improvement to this sort of human level performance and getting these things into production, into the hands of users. I want to introduce in the second half of class the midterm, and we're going to have a little jive sesh with everybody to discuss how we're going to set ourselves up for success in the second half of the course. So for today, fine-tuning embeddings, SDG, we're going to take some data about AI regulation that has some legal jargon in it and see what we can do to bring embeddings even closer to our data. Let's remind ourselves about fine-tuning embeddings by first reminding ourselves about RAG. We want to avoid hallucinations all the time through retrieval, through better answers. And the way that we're doing that is we're doing this dense vector retrieval and then putting the stuff in context that we retrieve. So the idea here, the question goes to the embedding model. The embedding representation is used to search for the data, set up the prompt template. We return the stuff that we found. This is the retrieval process. And this is our model that we want to take a look at today. This is the model that we want to basically have our source documents chunked up and pumped through to put into the database. And then it's the model we want to use to assess how close the question that we ask is to the stuff we put into the database. In other words, we want to map our data and our queries into the same embedding space, and we want to search our data for stuff that's similar to our queries. Similar meaning that it has the same sort of semantic meaning that makes it relevant to put in context, right? To put into the prompt. And now this is our RAG system that we can pump in and do the generation into the chat model. On Thursday, we will discuss how to fine-tune chat models, whereas today we're discussing how to fine-tune embedding models. What's an embedding model? We talked about this in session 2, but the input is, you can think of it as words, tokens, sentences, chunks. The output is numbers, stuff we can calculate. So the input and the output need to mean the same thing. If we have a good embedding model, then that means the stuff that is similar is going to be close together in embedding space. And we've seen this before. We've talked about this before. There's many ways to visualize embedding space that we've looked at. And for RAG, in particular, our input is the question, and our output is the context for our retrieval system. So what we want is we want to make sure that for our RAG application, the question that we put in is close to the relevant context we want to take out and put in context. And this is the fundamental idea behind domain adaptation of retrieval. Fine-tuning in general is about teaching the LLM how to act, how to behave. It's teaching the embedding model, more precisely we might say, how to adapt to the specific data that we're using that it wasn't trained on, okay? And of course, an embedding model is an LLM. It is a large language model. And if this sentence doesn't instantly make sense to you, you have some work to do to go down inside the transformer. That's what our 5-day email course is designed to do. It's to send you down into the transformer to understand more about attention layers, more about transformer architectures, more about how the original transformer included an encoder and a decoder stack, whereas now when we're leveraging GPT-style models, these are more decoder only. But embedding models, they're more encoder only. Now, if you just use a bidirectional encoder representations from transformers, a BERT-style model, Distill, BERT, Modern BERT came out not too long ago, you'll see that what comes out the top is, well, stuff that just gets pumped into another area that's also in embedding space. So what comes out of the top of an encoder is just an embedding representation. That's why it's good to use BERT-style models as embedding models, because that's all we actually want is the embedding representation. Language goes in, calculations, embedding space with vectors, calculations, embedding space with vectors, pops out next token, repeat the process. If you don't understand the next token prediction process, that's okay. You don't have to be able to build with this stuff, but it will help more and more, especially as we see multimodal models and other things come onto the scene, for you to understand exactly what's going on. So we can do the math with these embedding representations. We can use encoder-only models transformer models that leverage attention, but don't do next token prediction to look at what these are good at. Understand the input, locate it in embedding space relative to other things. Remember the embedding spaces we talked about before? We looked at 2D embedding spaces. We thought about many thousands of dimensions of embedding space to be able to map specific words against one another. Well, this is a way to think about comparing words or token level embedding representations. That's not actually what we're doing in RAG. What we're doing in RAG is we're doing sentence level. We're doing chunk level. And so we need to compare our source sentences or queries with other sentences. And unsurprisingly, sentence transformers from Hugging Face helps us to do this. It helps us to compute embeddings efficiently. Look really quickly, is it similar to this or that? And then select K results to retrieve back that we then could re-rank, or we could do all sorts of fun advanced retrieval stuff with that we'll talk about later on in the course. Embedding models today, we see OpenAI's, we've used it a lot. There's a lot of open source models. You can go on to the massive multilingual text embedding benchmark on Hugging Face and pick one out. We're going to use one today. It's called Snowflake Arctic Embed Medium. It's going to help us compare source sentences to other sentences. In other words, chunks to chunks. In other words, our queries to our retrieved context. Remember, our retrieval system must retrieve the right stuff. That's the whole point. And so when we set it up, we want to look at different ways that we might enhance our RAG application. There's many ways. But embedding model fine-tuning is a pretty easy way to get kind of guaranteed quantitative results. And the way that we do that is through this synthetic data generation process and the subsequent supervised fine-tuning process. Just like any training process, we need an input and an output, and we'll pay attention to the loss function. All of this is considered prerequisite material. Here, input is question, output is context. And what we do is we basically take the data that we have, we synthetically generate a bunch of question context pairs, and then we fine-tune the embedding model. Easy as that. So when we set up the vector store in the first place, we're actually taking our raw documents, pumping them through the embedding model, putting them into our vector store. What we're doing here is we're basically saying, well, the stuff that we have in our vector store, how can we go ahead and just use that? How can we create some context chunks directly from our data, right? And then what do we need to do? Well, let's go ahead and try to create what might be the questions for those context chunks. Remember how Ragus was saying, what theoretically could have been the question I might ask to get this context? It's the same idea here. We're going to do a synthetic data generation with now a chat style model, not an embedding model, to take chunks and to generate questions. Once we have our chunks and our questions, we can then use those and do the fine-tuning on the embedding model. And the fine-tuning is not a complete new retraining, but rather it's more like a rewiring. We're sort of getting specific neurons to fire or not fire, but we're not sort of changing whole cloth, really core foundational elements of the model. We're sort of, again, doing this finer tuning here. And so Wiz will walk us through the best ways to think about this. We'll go into deeper detail on some of the ways that we're actually doing this, like to pull the model down and to hold it, and how exactly we deal with very, very big models and how much GPU compute and all that kind of stuff. Because we start to get into that space here today. You will need a GPU for today. And the question context pairs are then paired with this specific type of loss And really, there are many different types of loss. One of the ones that we like to use in here is called Matryoshka loss, if you're familiar with that. Those Russian dolls, the Matryoshka dolls. This is a very well-named specific type of loss function that really helps with ordering the dimensions that we're fine-tuning and that matter. If you've followed other fine-tuning types of content that we've put out, you might be sort of familiar with looking at signal to noise ratios during fine-tuning across different layers in the transformer network. This is all sort of the same kind of intuition behind all of this. We want to only do stuff that really is going to move the needle and matter when we're doing stuff like domain adaptation, we're doing stuff like fine-tuning. So specialized domains are good for this. Think about legal jargon, doctors speaking, doctors speak, researchers in their specific academic discipline using fancy words. It's really important to be able to go ahead and just do this with your data because it might help. And there's one other additional discussion that we'll have after we do the fine-tuning in the first breakout room, which is how exactly do I pick the embedding model that I should use if I'm doing this in an open source way? We're going to use Snowflake Arctic Embed for today to do AI regulation embeddings, where we're going to take some EU AI Act data, looking pretty jargony already, and we're going to say that this is a good candidate for this because there's big words, there's lots of jargon, it's a specialized thing, and the specialized definitions probably matter here. So let's see how to do it in the notebook. And buckle up, everybody. This might be new to a lot of you, so Wiz, over to you. Everybody wants you to spend more time on the code as we go through it. Okay. Over to you.
Oh yeah. Okay, so fine-tuning embeddings. This is the good stuff. This is the magic sauce, right? For a lot of these embedding models. There's a couple points that we'll want to spend some time on, in addition to just walking through this code a little bit slower. Okay, so first of all, what is fine-tuning embeddings? Greg gave us a great overview, but the actual factual implementation is that we have some questions that we wish to be closer, quote unquote, in embedding space, right, to our contexts. We do this because for the most part we have an awareness of how a user is going to interact with our system. In this case, let's say RAG, right? We know that the user is going to do things like ask questions about documents in the corpus. That's the idea. That's the whole point, right? So what we're going to do essentially is we're going to make our embedding model very good at exactly that task, right? This is another instance. So we saw this last time, right, when we talked about like creating that SDG set. This is another instance where we care very deeply about the corpus of knowledge that exists. So we're not going to concern ourselves with feeling like we're overfitting the model. We are, in fact, most definitely overfitting the embedding model, right? We want the embedding model to be very good at our corpus. We care not for it to generalize outside of our corpus because, there is no outside of our corpus that means anything to our RAG system, right? We want it to be very good at specifically the corpus of documents that we have. Okay, so what we're going to do is we're going to create these pairs, right? Now, right away, you can kind of tell that these pairs are like, they're related, right? But they're not super related totally. We have like the bus was driven by Kyle, the bus driver. Okay, that makes sense. So bus is here, right? Drives and driven is here. But the idea is that like the questions people ask are not often going to contain keyword soup like we would have for basically, right, the users are not going to ask questions correctly is the way you can think about it. People have learned how to Google real well. People have not learned how to RAG real well. Generally speaking, there is a lot of people who do this. Lee asks, is this supervised Oh, it's supervised. We're supervising this process. Don't worry. Okay, we're going to go into exactly how as well. But the idea is that we want our document retrieval to work well for the thing we need it to work well for. So this is why we're fine tuning. There's a question. Describe the nuance between using question document pairs to train the embedding model versus inter-document pairs related sentences. I've provided the answer since this is a bit of a doozy of a question. But think about it in your breakout rooms. You know, come up with some additions or amendments to the quick answer I've provided. But the idea is that there is some reason why the question document pair is better than just inter document sentences that you'll want to have a small discussion with your groups about. We're going to need nest async IO because we're going to be running nested async loops in our Colab notebook. This doesn't really mean anything. The idea is that Colab is running an async loop, and in order to run an async loop in that async loop, we need nest async. There you go. We got a bunch of dependencies. If you're using this notebook locally, do not install this pip cells. They should be commented out if you have the local notebook version. So you can safely ignore them. Thomas asks, what are the inter-document sentences? They are sentences that exist between documents, basically. That's the idea. Okay. The reason this is important is we might have like 40 documents, right, that we want to drag all together. And so, you know, making sure that we have consistent embeddings across all those documents could be useful. It turns out perhaps not very. We need our OpenAI API key, of course, and we're going to use some datums today that are filled with words that are specific to the they're specific to a specific domain. We're going to chunk those datums up in order to make sure that we're not just using one or two documents. Chunks of 750, overlap of 20. The length function just Python len. There you go. Okay, it doesn't matter. We're just creating synthetic data. We're going to load and split these documents as follows. We're going to use our text splitter to split them. We get 102 final documents. That's cool. Everyone loves that. Now, we're going to then do this thing. This is I've got many pieces of feedback. Like Greg said, walk through the code a little bit better. So we're going to take a small pit stop here to explain what the heck's going on. So UUID is just going to generate a unique identifier. Okay, it's just like a string that should be unique. Then for each document in our training documents, that's each one of these split documents in our 102 documents, we're going to generate a UUID for that document. We're going to do this check just to make sure that we don't generate duplicate UUIDs. This is, in fact, extraordinarily unlikely, but just in case, right, we do the check. And then for each of those documents, we add metadata called ID, which is going to contain this unique identifier. You might ask yourself, why do we need to do this? Who cares? This will make our training process much more simplified. So the way we're going to train this model, right, that's the goal here, is going to be made easier through this process. So that's why we're doing it. Basically, every piece of document or every chunk gets its own unique identifier, and we verify that it's unique so that training is easier. And then we're going to split things up. And we're just going to use naive slicing, right? So we're just slicing based on the length of the total documents, easy peasy. We're basically going to have a total of, n minus 24 training documents, and then we're going to have 12 test and 12 validation. This stuff is very machine learning-y, so if you're not sure what's going on here, the big idea is that we want to be able to see how our system is doing while we're training it, so we have validation, but we also want to see how our system does after we're done training it and have some kind of thing that we never train on. That's our test set to verify if it's doing well or if it's not doing well. So that's why we've done this train test validation split. Okay, then we're going to use GPT-4o Mini to create synthetic data, and this is easy enough. We're going to create the model. We're going to create a prompt. and we're going to have it generate n questions, which is something we can just pass in, and it's going to do that. We're going to use a chain for it to do that. And all we're going to do is for every question, right, we're going to generate n for every chunk in our corpus, or every document in our corpus. We're going to create n questions that could be asked about that piece of context, right? So the idea is the idea is that we want to have some number of questions where each of those questions are related to a specific chunk, right? This is because we know at the end of the day, we need pairs between questions and context, that's the idea. That's what we're trying to walk away with. And so in order to do this well, we want to provide, we want to create those questions. That should only be about that context, right? We want to build a positive sample. And then this UUID thing, again, we have to do this UUID thing. And this is largely due to making it easier to run later. There you go. So you're going to have these things, right, which are going to be just chunks of contexts and chunks of questions that are associated through this object that maps between a piece of context and its question, right? And then you're going to have to write code here. Now, if you're doing this locally, that's an extra bonus for you. Cursor is going to be able to do this very straightforwardly for you, right? You could ask it to do it, and it likely will. If you're doing this in the collab, you might have to use your resources a little bit more strategically. This is an important point to bring up now. If you don't have a GPU, or if you don't have an M1 Mac, please run this notebook in the collab environment. The reason I'm saying this is that we do have to train a little model. It's not very big, but it does take time. It will take much longer on CPU than it does on GPU. So if you're doing this, if you have a GPU or an M1 Mac, you're covered. But if you don't, we're going to use the collab instance. We're going to go to our runtime. We're going to go to change runtime type and make sure we're on the free T4 GPU. That'll be easy peasy for you. All right. So this is the template for our function, right? This is our little signature here. You'll notice that we're using this async. If you decide to go with the synchronous solution because that's what you're comfortable with, please remove the awaits here. There's a big block. The hint is just use async. You know what I mean? There you go. But then we're going to go ahead and we're going to create all of these questions, and that's going to be great. We're going to save them so we can use them later. And then we're going to finally get into fine-tuning. Snowflake Arctic Embed L. This is the large boy. So L is for large. It's even bigger than medium. It's still very small. The reason we're going to tune L is just to show its ability to match kind of, state-of-the-art closed source embedding model. We're going to get some extra dependencies. Again, this will be commented out if you're local. Don't worry about that. And then we're going to use sentence transformers to load the model up. All that's happening here is we're fetching the model weights from from Hugging Face, and then we're putting them into memory. If you're in a GPU-enabled instance, you're going to be putting this into your GPU memory, right? It's going to tuck it away in there so you can train real fast. If you're using your M1 Mac, this will be put into unified memory, so you can train it up real fast. And if you're using this on a CPU instance, which I strongly recommend you don't do, but if you do, it'll just be shoved into RAM where it will chill. But the idea is that we're going to load the weights and then shove this into our memory. You'll see that the weights are not very big. It's a small model, right? That's the idea. But there you go. Then we're going to use some Torch. We're not actually going to use Torch at all, so don't be scared. If you see PyTorch, we're not really using it. We're just using it just the tiniest little bit. But please look into PyTorch. It's amazing if you want to go deeper into this stuff. We use a batch size of 10. This is just to accommodate the limited hardware that we're going to use, since we're bound to kind of that T4 instance in Colab, the free GPU. And then we're going to just make sure our data set's in the right format. We're going to create a data loader, which is going to load data in this batch size. The way that a data loader works is basically it's like a pool of data, and we just rip stuff out of it, and it's going to come out in batches of 10, and it's all going to be in the format that we expect. The reason we use a data loader as opposed to using a different a different kind of process is because the data loader is fast, and we care to be fast right now. Then we're going to use Matryoshka loss. Okay, now this sounds intimidating because it's a big old word, but if you know Matryoshka dolls or Russian nesting dolls, right? This is the same thing, but for our embeddings. So you can imagine that our whole list of embeddings, our whole vector length is 678, okay? However, what Matryoshka loss does is it helps us train our embedding model such that the most important embedding dimensions are at the front of the vector. So basically what that means is you can just remove the ones at the end and you're left with only the most important. What this lets us do is set dynamic embedding dimensions. So this is how OpenAI is doing it under the hood, right? This is why you can select your own value for how large you want those vectors to be from OpenAI's endpoints is because they've used this Matryoshka loss. The reason it's most important for us is that it lets us choose how big our vectors want to be. And you might ask, why would we need to choose that? Well, imagine I have 10 billion vectors, right? Choosing my vectors to be 768, elements long versus 64 is it's gonna be a very big difference in storage cost, right? I'm gonna be able to pay much less for storage if my vectors are 64 in length versus 768. So this is why Matryoshka loss is important, especially as we get to this big scale. Being able to store these vectors in a very small, tiny little box, which is still very information rich, is going to be extremely important. The core loss we're using is called multiple negatives ranking loss. Again, there's a lot of words here, but all this means, remember when we created our question context pairs up above, right? Well, what multiple negatives means is that every single question context pair that is not the one we're currently looking at is considered to be a negative example. So this is going to help us do something called contrastive learning. All that means is that we're going to say, hey, positive is good, negative is bad. But basically for every row in our data set, every other row is going to be a negative example. That's going to help us train our model to be very, very good at picking up exactly what we want it to be good at. So this is it's a way for us to exploit the fact that if a question is only about one piece of context, that means it's not about any of the other pieces of context, right? And so we can exploit that to train the model real good. So that's our loss. We care about loss. Loss is the best. We love loss. Okay, then there's an activity for you. You're going to summarize this. There you go. Boom, boom, boom. Easy peasy. We need an evaluator. This is going to use an IR evaluator, information retrieval. Basically, did you fetch the right stuff? That's what we're saying. Did you fetch the right stuff or did you not fetch the right stuff? If you did fetch the right stuff, you get a cookie. If you didn't, you get no cookies. Move on. We're going to train our model for 5 or 10 epochs. If you're running into time issues, by the time you get to the model.fit part of the notebook, just reduce this to 5. It'll be fine. We're disabling wand B, so you don't have to have a wand B key. And then we're calling model.fit. Okay, model.fit is the one. That's the thing. That's the best thing. It's so good. Let's go. We have our training objectives, which is just going to be our loss. We also have our loader, which is our data loader. Number of epochs, how many times we're going to run through all the data, right? How many warm-up steps we're going to do. Don't have to worry about this. And then like show progress bars. So we get this nice little bar, right? You can see that. And we're going to evaluate every 50 steps. There you go. So we train the thing and then we evaluate the thing. The evaluation is very straightforward. There's a big old function here. All this function says is, did you get the right context? If you did, again, you get cookie. If you didn't, you get nothing, right? You get no score. Very sad. It's a lot of lines of code because we're being very verbose about things. But the idea is that we just set up, expected information. We use our vector store with OpenAI to pull some context out, and we determine if it was correct. If it was, we get score. If we don't, we don't get score. All right. Then we do the thing. We evaluate. So we use OpenAI's model, which is the text embedding 3 small, and we get a hit rate of 1.0, which means 100% of the time, we get the correct results with OpenAI's embedding model. Okay. Then we test it with the base Snowflake model, where we only get the correct response 91.6% of the time. Now, that's less. That's not 100% of the time, right? And you might say, well, why not just use this? Well, we have to give away our data to OpenAI, et cetera, et cetera. It's expensive, blah, 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 right? But 91.6 is good. It's not great, right? We don't want like an 8% error rate in our RAG application. That's silly. So when we fine tune the model, we find it gets right back up to 100%, right? 1.0, let's go, fine tuning works. We're gonna do a quick vibe check where we build a RAG chain. We've done this exactly before, so I'm not gonna spend time on it here, but you can go back to the previous notebooks or previous recordings if you wanna learn about that. And this is just showing that with our base RAG, we're doing pretty good, but we can't answer some questions that are very specific to the source material, right? These are very specific questions to the source material that it gets wrong. And then when we use our fine-tuned model, it gets them right. That's the whole point of it, right? These are not heavily cherry-picked examples, but the idea is that the embeddings are more representative of our corpus when we fine-tune than when we don't. There's an evaluation part that's for you that you can do on your own. Please don't do this in class, but the idea is that you can work through this. It's exactly what you've done already in last week's notebook, just for this instead of what we did it there. Anyway, with that, we're going to get to breakout rooms. I've gone perhaps just a slightly too long here, but hopefully it'll make it clear when you get in, and I'll pass you guys back to Greg to get us to breakouts.
All right. Yes. Thank you, Wiz. Okay. We are going to go to break rooms now, and a couple things. Number one is this is going to be the only coding breakout room of the day. So if you start off down the Ragus thing and in the task 2, you're going to get cut off for sure. I just have one question, Wiz, maybe to set the context a little bit more for everybody. This seems like a lot of stuff that we're now just sort of bringing in. Like, is this really necessary for us to know how to do fine tuning of models today relative to RAG and agents and all this stuff we've already learned and it feels like gone deeper on?
Yeah, that's a great question. It's where it exists in our sessions, right? That's the priority compared to the other things. So this is not as high a priority as being able to implement RAG, re-ranking. This is not as high a priority as, say, understanding how to build agents, right? But it is something that is low-hanging fruit. As you can see, though you might not, it might take you more time to fully grok the depths of what we're doing, right? It's something that we can do in a single notebook that's not that long, right? And it adds tremendous value. Like, this is when your RAG app is not working well in terms of you're not retrieving the right numbers or documents, right? Ragus is telling you retriever scores are low. This is a great place to just be, okay, well, it's going to take me, a grand total of a day's work, and my embedding model will be much better. That's a easy low-hanging fruit to make your app work better. But again, it's not, it's in the priority of when it appears in the sessions.
That's right. And it used to be more important than it is today, but it's still like hanging around. Okay. So we'll continue to chat about it the rest of the week, chat about it in your breakout rooms. Enjoy. We'll take a quick break after our 25-minute breakout room, and we'll mix it up for the second half of class. Enjoy, guys. We'll see you soon. Back. All right, and we're back from the break. I wanted to just cover real quick this idea of choosing the right model. And, Wiz, there's this thing that they have. It's called the Massive Text Embedding Benchmark. It looks like it's been updated to the Multilingual Massive Text Embedding Benchmark. And the whole idea is that no particular text embedding model dominates every single task. And we've sort of put this out there before for folks where it's like, well, how do you choose, right? And like, when you look at all of this stuff to choose from, parameters, memory, metrics, benchmark data sets, how do you even navigate this, like for any given problem space exactly? How are you thinking about this today?
Yeah, I mean, it depends on where you're approaching, the application from. But if you're let's say most concerned about highest performing, then it's very easy. You pick the one that does the best on the metric you care about. If you have some kind of right size hardware issues where you're like, okay, I have X GPU or X GPUs that I'm going to use, and that will sustain two simultaneous llama models with 8K context length. That then the parameters and the context are kind of handled for you, right? But otherwise, I think what you want to do is build your solution, right? With whatever embedding model, and then do the experiments. These models are extremely lightweight, for the most part. They're very fast, so doing that experimentation should be relatively cheap. In terms of both labor and actual, hardware costs, to get the right fit. But if you're like just struggling where to start, sort by the metric you care about and pick the top one. If you are, again, in a situation where you have limited hardware, choose the smaller model, 500 million params, right, as opposed to like 1 point whatever billion. But now we have NV embed llama 1.x billion, which has an 8K context length. It's only like 1 point something billion parameters. So it's, we have so many awesome options that it's very difficult to go wrong as long as you're near the top of the leaderboard.
Yeah,
your desired metric.
Okay. And if you're not using your own data, I mean, you can just pull OpenAI's off the shelf like we've been doing the whole time, right? And see, like, is it doing the job? And in general, if your supervisor asks, it's like, we should use the smallest one that gets the job done, boss. And you can say some of the things that Wiz just said. Well, we should look at what it's good at, choose the less than 500 million parameters, check performance, and then we should go back and we should look. If we didn't do it well, maybe we should rescope the problem. Or if you just have cash that you're looking to light on fire, just pick the biggest, baddest model from the MTEB leaderboard, which today is this Link Embed Mistral. I just want to show everybody the leaderboard real quick, Liz. It's actually evolved even since last time we taught the thing. So there's a lot of new options on here. Okay, so I'm just going to refresh it here. And you'll notice it's the multilingual now. So when Wiz, you said choose the thing you want to do. So I'm just going to go ahead and say, okay, English is probably fine for what we want to do here. Task types. Oh, look, I have retrieval there. Oh, that looks relevant to us, doesn't it? So let's say if I go boom, 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 I get this nice plot now, this beautiful plot. I can like mouse over stuff. I can also go down here and I can look. What are you looking at when you get down here, Wiz? I'm looking at number of parameters. That's a big daddy right there. What else is worth looking at here exactly?
Almost nothing other than your metric that you care about, right? So especially because what we're going to do is we're going to fine tune this artifact, right? So we're going to do this extra process, right? So what we need to be true is that it is on the list, it fits into our GPU or our hardware, and then from there we're going to go ahead and we're going to fine tune it to be custom tailored to our solution. Something else that's important to realize is fine tuning helps us get away with smaller models, right? Because we're fine tuning them for our corpus. So you don't have to reach for your 7 billion parameter model for your embedding model if you're going to fine tune it anyway. Yeah.
Perfect. All right, well, that's it. And basically, I think the takeaway here from this session was, if you can fine tune embeddings for RAG, I mean, it gets better. Look at the Ragus. Why not just do it, right? I mean, it's not that expensive, all things considered, right?
It is the first thing I would reach for after re-ranking in every case, because it just makes the system better at the documents that you have, which is what the system needs to be good at. So that's
what a great segue. Thank you for your insights, Wiz. And with that, we're going to go ahead and take a hard pivot, but it's not that hard, into thinking about how we're going to build, ship, and share something really legendary. I want to go back to what we talked about in the first session. How do we build prototypes? Should I use RAG? Should I use fine tuning? It's like, Yeah, probably should. It's like, should I use agents? Should I use RAG? It's like, well, yeah, you probably should. And generally, there's going to be sort of a sequence in which we do this. We're going to do prompting, we're going to do RAG, and then maybe agents first, and then maybe fine-tuning later. And now you'll start to sort of understand how this is evolving and why it's less clear than it was last cohort, that maybe agents comes before fine-tuning now. Remember, prompting is putting instructions in the context window. RAG is giving the LLM access to new knowledge. Dense vector retrieval combined with in-context learning. Fine-tuning is teaching the LLM how to act, how to behave, how to adapt to specific language and agents. We can think of it as fancy RAG. We can think of it as giving the LLM access to tools. We can think of it as the reasoning action pattern. When we go from prompting to RAG, we're optimizing what we put in context. When we go from prompting to fine-tuning, we're optimizing the LLM's inputs and outputs and the way it acts, the way it behaves. We need both of these in general, and we can put agentic behavior really anywhere. When we talk about fine-tuning, we talk about fine-tuning both embedding models and chat models. And remember, maybe we'll start off with a simple prompt. One shot, two shot, few shot, add it in. Do the evaluation with just simple eval, little vibe checkerino, right? RAG comes next. Then maybe optimize your chunk size. Is this really what I'm looking for? Maybe just use the default. Maybe then give it some access to tools. Maybe then give it access to some open API. Maybe then enhance retrieval a little bit. Or maybe fine-tune embeddings instead. Or do some re-ranking, which would technically fall in this sort of advanced retrieval process that we'll talk more and more about different types of retrievers, different types of retrieval that we might want to do. And finally, maybe we're fine-tuning the chat model. Maybe we're only doing that so we can use a smaller chat model that is going to really balance performance with cost and efficiency. But before we do any of that, we have to figure out what we're going to build and why. We have to figure out how to do the appropriate amount of AI product management because we know enough AI engineering already. We know enough to really be dangerous and to build prototypes. And so in your midterm, what we're going to do is we're going to put all this together and we're going to get you guys on the path to building, shipping, and sharing something really awesome for Demo Day. So the idea here is that we're not going to tell you what to build and why. We want you to articulate the problem, the solution, and who you're going to be building it for. Last time when we taught this course, we articulated the problem, the solution, and who we were building it for. It turned out that it wasn't very helpful for people to be told exactly what to build and why when they needed to prepare a demo day project anyways. So this time, we're putting it in your hands, in your journey group's hands, in the hands of the larger cohort. Today, we're going to have one breakout room, and it's going to be with your journey group. You don't have to figure out everything today. It's not even part of your homework. Your midterm will be assigned next Tuesday, due the following Tuesday, and it will be the only homework you have all week. Next Tuesday, Wiz and I will walk through this entire process in one example. We're going to also open up breakout rooms so you can meet other students, so you can meet other peer supporters. Of course, everybody must submit their own midterm if they'd like to get certified, if they'd like to participate in Demo Day or join a team for Demo Day. I'm going to give you guys specific deliverables, and the grading team is going to look for these. I'm not going to give you all of them now because it's not really relevant right now. Deliverables for the data might look something like describe the default chunking strategy that you'll use. Articulate the chunking strategy. These are the kinds of things that you're going to be asked to do by somebody overseeing your projects if they really do know the details. And specifically, why? is the question that's always going to come up. Oh, you did that? Why? Oh, you did that too? Why? Oh, you made that decision? Why? This is what we want to certify you in, because that's what's going to open up opportunities for us to put you in front of the right people and give you the right opportunities, because we know that you're going to crush it and knock it out of the park. To do something like agentic RAG, what does that even mean, first of all? Maybe that's a question on the midterm. But it's going to be build a prototype that other people can use. Has access to agents, has access to RAG, that's fine. Nobody cares. They only care about what it's like when they use it. And there'll be more deliverables. And I'll articulate them fully next week. We have a lot to talk about on Thursday with fine-tuning and our own reasoning model. What I want you guys to talk about today is I want you to spend some time with your groups. And ideally, you have a problem in mind already. You are talking with Lusk already about figuring out problems in your organization. You have a startup you want to build. You have a community that you want to contribute to. You have someone you're interested in building for, even if that someone is you. And so we want to give you guys some time to hang out, to talk about problems and solutions. This is the way every single accelerator you could join on the planet is going to work. This is the way every single large enterprise wants their new startup-y AI group to behave. They want to figure out what the problems are. Then they want the AI engineers to attack them. This is important, but sometimes very boring work for people that don't like to do this kind of thing, but it's necessary if you want to be a unicorn AI engineer, and it's necessary if you want to have a great story to tell for demo day. So whatever you're doing, this will be helpful to you, I promise. Trust the process. Enjoy the time with your room. We're going to give you guys 20 minutes to hang out and to talk about ideas. There are no requirements for you to submit anything based on today, except the homework on fine-tuning embeddings. Let us know if you have more questions in the chat when you come back. And hopefully you guys will have some problems, some solutions, and some audiences to build, ship, and share for heading into next week and into the second half of the course. Enjoy the breakout room. We'll be back to close it out Tuesday, session 9. See you soon. Quick. Back from the breakout rooms. There was one question that was quite interesting, because you'll notice it's not on the slide. And it's, where do we find data? Well, the first thing I would say to that is go to Hugging Face datasets, or you can generate data using SDG, of course. But you shouldn't be worried about data until you articulate the problem. Really specifically articulate it. And once you do, it's going to be obvious where to go to get data, or how to go about generating it yourself, which any peer supporter can help you with. So if you have other questions, please do throw them into the chat. Kaggle, of course, what an absolute classic. Steal and then ask for forgiveness, also a classic. Yeah, I think Ashwin's got some ServiceNow data. Maybe he can help you out. Okay, let's go ahead and wrap today, guys. What did we learn? Well, we learned about fine-tuning embeddings. We learned that we can use open source models and get them to approach asymptotically the performance of closed source models. This is going to allow us to keep our data private, not give it to OpenAI or Anthropic or whoever else. And that's really useful. We can fine-tune models quite easily with performance improvements. It's big dope. And this is something that will continue this week. We'll talk more about fine-tuning, but we'll talk about fine-tuning chat models. And this is a slightly larger subject. These are bigger models, so we have to deal with the size issue. Also, in general, we're going to have to deal with how to actually think about using fine-tuning. And it's not always just for cost optimization, although more and more I think we're going to see it used for that. It's going to be quite interesting to see how people take commercial off-the-shelf models and adapt them to their use cases, in addition to all of this stuff around the models. Again, if you need help, come find us this week, and note that Vincent is doing the deep dive on Thursday before we see you again. More on eval if you want to get some more eval. Join us tomorrow to talk about DeepSeek. We'll give you our take. We'll go much deeper. Then we will be able to go in class talking about fine-tuning on Thursday, although we will expect to be fine-tuning some reasoning stuff, which should be a lot of fun. And with that, we'd love for you to fill out some feedback. I've got one question in the chat here. Does it make sense for me to think of next week as grind on the midterm project? I think it makes sense for you to think about it like that. Yeah. Great question, Dirk. 2 minutes on the clock. Feedback. Let's go ahead and keep the vibes rolling. Thank you, everybody, for filling out the feedback. I'm loving the chat going on in the Zoom chat. Let's keep it rolling in AIE5 General. If you have ideas about how you're going to gather data, about your projects, feel free to do a little building in public here within the cohort community on Discord. You don't have to go public and build, ship, share it, but maybe you should along the way. It is only week number 5 after all, and we've got a long way to go in this journey. We got enough to be dangerous, and we're excited to keep it rolling with you guys into Thursday, where we'll talk fine-tuning of chat models. And then next week will be a little bit of a reprieve for all of you guys that have been working really, really hard to spend some time working on what hopefully matters to you guys and will help you get where you're trying to go. Thanks for joining us for session number 9, Fine-Tuning Embeddings, Domain Adapted Retrieval. We'll see you on Thursday, or maybe on YouTube tomorrow, to talk fine-tuning and build our own DeepSeek R1 style reasoning model. Thanks, guys. Have a great evening. We'll see you again real soon. Don't forget to shout out those peer supporters on the feedback form. Let's go. All right, guys.
Hi, everyone. Oh, Nick has a question.
Oh, this is a more nerdy question that people can ask. It's more about, is there a risk of overfitting when you're fine-tuning embedding models? Like, what's the minimum question retrieve context pair you need to have such that when you have a new question, it's like, I have no idea how to answer this now. I mean, I know it's just a minor rewiring when you're doing an adapter, but like, what's like the best practice for that?
Yeah, I mean, we don't care about overfitting nearly as much as we might with more traditional flows, simply because we're essentially trying to overfit to our corpus.
Yeah.
But you have a valid point. I would say yes, you should try and make sure that you have, say, 2 or 3 questions per relevant chunk. And we want to, you'll see the advanced task in the GitHub README, right? We want to use like a more involved process to generate those questions than just as naively as we did in the notebook today. But if you have 2 or 3, you're probably starting in a good place. Yeah.
Yeah.
I mean, is this something where you'd actually want like if I'm using llama index or I'm using unstructured, and during the processing step, why not just take that chunk and then use SDG right then to like generate a hypothetical question, right? What's the difference between that and then versus having like a ragus test set of then embedding the fine-tuning model? Like, could I not inherently just like use that metadata as one of the things that I'm putting in a retriever versus having to fine-tune an embedding model altogether?
We actually still do want to fine-tune an embedding model. So you're correct that there are other ways we can think about sourcing or collecting the data sets, depending on the maturity of our application. Like the best thing to do, so the absolute best thing to do would be hopefully the most obvious thing to do, which is just use user questions and find the best chunks using some involved, expensive process, right?
Yeah.
Data set. Yeah.
Yeah.
But,
Like, of course, that will be the best way to do it. What I would say is that we're not usually starting from such a privileged position, right? We're starting more thinking about how to start from more whole cloth. We don't yet have that volume of users using our application. But yeah, whatever system you design such that It is doing what it needs to do, which is getting data that's representative of user questions and pairing it with the absolutely sure correct context, up to and including, the context is not there, and so maybe we should think about how to handle that case
Yeah.
as well. Whatever you can do to make that happen. Yeah.
Yeah, I mean, this is the raggest like production-driven development argument,
Yeah.
right? And I think like I wish there could be in the same way we have chain of thought, like chain of search. Like how can we get users to be like, oh, this is a shitty answer. Now record my screen and let you go to the actual source that this was from.
Yeah. We continue to engineer IR systems to get better and better as time goes on, but for now, we're working on it. Great questions, though.
All right, guys, we got to run.
Yeah, peace.
All right,
Thank
thanks,
you.
everybody. See you Wednesday. See you Thursday.
Bye.